Breaking with 30-plus years of convention and taking wheel balancing technology to the next logical step, Hunter's SmartWeight wheel balancing software provides a much more intelligent method for balancing today's wheels. Uniquely tuned to handle a vast array of wheel sizes and designs, SmartWeight gives you an accurate and repeatable balance and saves you money on correction weights every day. Wheel balancing has evolved from single-plane static balancing to two-plane dynamic balancing with the focus on 5-inch wide 15-inch wheels. Most wheels had rim flanges, and balancing was performed using clip-on style correction weights 90% of the time. But today, wheels are dramatically different. Diameters ranging from 13 to 26 inches, rim widths from 4 to 16 inches, and assembly weights that approach 170 pounds are an everyday occurrence. And rim flanges have all but disappeared. So now most wheels are balanced by attaching adhesive weights on the inside. Because of this, it takes more time and larger amounts of correction weight to complete the balance. In respect to today's wheels, most current wheel balancers have two deficiencies in logic, which result in excess wheel weight consumption and time-wasting check spins. The first deficiency is applying the limit, or tolerance, to which the wheel is balanced to the displayed correction weight instead of the actual vibration force. The second deficiency is applying the same tolerance to both imbalance conditions. In most cases, it's too tight for the shimmy or couple imbalance, and in some cases, it's too loose for the static imbalance. As a result of these two deficiencies, the balancer will continue to call for correction weight until the vibration forces are completely canceled, and at times call for correction weight even when the vibration forces are not sufficient to cause a problem. Let's compare SmartWeight to the old method so you can see how this new tool works. After the measurement spin, the old school method will calculate the amount of correction weight and locate it opposite the imbalance found in each plane of the wheel. This wheel has a shimmy imbalance condition just above the tolerance, so the balancer is calling for 1/4 ounce of correction weight on each side. It's important to note that this small amount of couple or shimmy imbalance will never cause a problem on the car. In fact, based on manufacturer tolerances, it would probably take 4 times this amount. But because the old method applies a single fixed tolerance to the calculated correction weight, the technician will proceed to waste 2 wheel weights and the time to install them. The problem gets even worse when the correction weight has to be installed on the inside of the wheel. Since most wheels no longer have rim flanges, and most customers will not accept a correction weight on the outside, wheels are balanced by placing all the correction weights on the inside. When you do this, the separation between the weights decreases, which means the size of the weight has to increase to generate the same canceling force. This is why. The distance between the weights acts like a lever, much like a spanner wrench. Moving the weights closer together is like making the handles shorter on the wrench, which reduces its leverage. This means the force applied at each end, in this case, force applied by the wheel weights, has to get larger. In some cases, very large. Now back to the demo. If the correction weights are placed here, they would have to be substantially larger, possibly 1.5 to 2 ounces in size, to correct a very small amount of imbalance that will never cause a problem on the car. This is because the old technology applies a single tolerance to the correction weight instead of the actual vibration force. But this time, because we're installing weights on the inside, a large amount of expensive adhesive weights are wasted, plus the time required to install them. Now, let's look at what SmartWeight would do. When SmartWeight looks at this wheel, it measures the static force and compares it to the static tolerance. In this case, the force is below tolerance. It then looks at the couple, or shimmy force, and compares it to the couple tolerance. The shimmy force is also below tolerance, so the display shows OK. Whether you enter weight placement at the rim flanges or all on the inside, SmartWeight will tell you this wheel is balanced. Why? Because SmartWeight compares the actual vibration forces to individual tolerances. The bar graphs confirm this wheel is well within tolerance. On any wheel requiring balance, you can expect to use less correction weight, yet never at the expense of an accurate dynamic balance. Let's see how SmartWeight makes this possible. SmartWeight is best understood when you break it down into its two principal sections, the force measurement section and the weight saver section. In the force section, the imbalance forces are calculated separately. Static force is computed first, and then the static tolerance is applied. Next, the couple, or shimmy force, is computed, and then compared to its tolerance. If either force is above its respective tolerance, correction weight is calculated and sent to the weight saver section. When compared to the old method, you can see that the imbalance forces are never compared to tolerance. Correction weight is first determined for each plane of the wheel, and then a single tolerance is applied to both. Using SmartWeight, final weight correction is resolved in the weight saver section. Static force cancellation is emphasized, while up to 75% of the couple tolerance is used to minimize weight for this correction. The results are then combined to produce just the right amount of correction weight to balance the wheel to below tolerance. The force limit bar graphs will illustrate that both the static and couple imbalance forces are well within tolerance. Using less correction weight, while still providing an accurate balance, certainly defies convention, but that is exactly what SmartWeight does. Consistently saving weight on virtually every wheel balanced, SmartWeight will still give you the same smooth ride on every wheel serviced. To illustrate its accuracy, we'll compare the performance of a SmartWeight balance to a conventional balance and see if it is, in fact, just as smooth. To judge the performance of each balance, we'll use this uniquely designed sensing fixture. With this device, we can spin the wheel and see a graphic representation of the vibration force produced. If a wheel has pure static imbalance, the vibration causes the force pointer to shake up and down, and is displayed by vertical travel of the projected laser dot. Couple, or shimmy imbalance, will shake the force pointer sideways, which will produce horizontal travel with the dot. Wheels with both imbalance conditions will shake the force pointer in this manner. Very slight movement of the projected dot means the imbalance forces are within their respective tolerances. To begin, we'll check the wheel on the fixture. This type of vibration pattern illustrates the wheel has both static and couple imbalance. Now, we'll balance the wheel using standard software. With the weight placement dimensions entered, the imbalance is measured. Using the standard software, 2½ ounces on the outside and 1 3/4 ounces on the inside are required. The weights are installed, a check spin is made, and the wheel is removed from the balancer. Now we'll check it on the fixture. With the wheel spinning, the pointer is virtually stationary, as indicated by the projected dot. This proves the balance condition is well within tolerance. Next, we'll balance the wheel using SmartWeight. Mounting is performed in the same manner. The same weight placement dimensions are entered, and then the wheel is measured. With SmartWeight, 2 1/4 ounces of correction on the outside and 1 ounce on the inside are required. Compared to the standard software, this is a savings of 1 ounce of correction weight. The weights are installed, a check spin is made, and then the wheel is removed from the balancer. Spinning the wheel on the vibration fixture shows the balance condition is perfectly smooth. The pointer is virtually stationary, as indicated by the projected dot, which proves SmartWeight has done its job, and with a weight savings of 1 full ounce. With SmartWeight technology, you'll save weight and save time, but you'll never sacrifice a smooth ride. The average tire shop can easily consume as much as 3,000 pounds of wheel weights every year, and wheel weights are not cheap. The annual expense can be in the thousands, and costs will continue to rise. Every day, more coated and adhesive weights are required, and when lead is replaced, costs will increase 3 to 4 times. But by working smarter with SmartWeight, you can save on correction weight for virtually every wheel balanced, saving you dollars every day. Hunter's SmartWeight balancing technology provides a much more intelligent method for balancing today's wheels. Uniquely tuned to handle a vast array of wheel sizes and designs, SmartWeight gives you an accurate and repeatable balance, saves you money on correction weights, reduces labor costs, and allows you to make quick checks easier and faster. To give SmartWeight a test run, schedule a demonstration with your local Hunter representative and balance some wheels. In the meantime, visit our new website at www.weightsaver.com. Thank you.